This is a continuation from the video about Ohm's law, and here we shall see about resistance of a conductor. So if this is a conductor, okay, and if a current is passing through this conductor in this direction, then each conductor, they always have one unique property, that is to oppose the motions of electric charge, or we can say which oppose the motions of electric current. So that property of a material which oppose the motions of electric current is called as resistance of a conductor. Right? And this resistance of a conductor, it can be measured from the formula of Ohm's law, where we have V is equals to IR and R here is equals to V upon I. So this, from this equation, right, we can also define the resistance of a conductor as the ratio between the electric potential difference across the ends of the conductor and the current passing through the conductor. Okay, we shall also see here about SI unit of resistance. The SI unit of resistance is ohm, and symbolically we write like this. Okay, but when you look at this equation 1, the resistance, the unit, the SI unit of resistance can be obtained by substituting the units of potential difference and current. So therefore from this equation I can say the SI unit of resistance is volt per ampere. So this volt per ampere, it is equivalent to ohm. Alright, so again, as usual, because this George Simon Ohm, he was the first person to discover about the term resistance. So therefore, in order to honor his name, this SI unit is given in his name, that is ohm. So therefore ohm is equivalent to volt per ampere. Okay, now ohm is equivalent to volts by ampere. Now when I say 1 ohm, this potential difference also should be 1, current also should be 1. So what does it mean? It means that if I connect the two ends of the conductor, to a cell like this, and if the potential difference of this cell, let's say it is 1 volt, and this cell, let's say it produces a current of 1 ampere. So when a current of 1 ampere is flowing through the conductor, when the potential difference between the ends of the conductor is 1 volt, then the resistance of this conductor is said to be 1 ohm. Alright, so this is about the SI unit of resistance. Okay, again, right, let me explain about this equation once again. We have seen yesterday that when you plot the graph between potential difference versus current, then you get a graph like this line, okay, which is a straight line graph passing through the origin. Now this type of graph, it is true only for ohmic conductor. Whereas if the conductor it is a non-ohmic conductor, then you will not have this type of graph. Okay, now suppose I consider any 2 points on the graph. Let's say this point A and point B. Alright, so if you drop a perpendicular on the x and y axis, you get this much. Okay, let's say the amount of current here is 1, the potential difference here also is 1, the current here is 2, potential difference is 2. So when you take the ratio, when you find out the resistance from this graph, because from the equation R is equals to V upon I, so the resistance of the conductor at this point and this point, okay, it is same, which means the ratio between the potential difference and current, what is at point A, VA upon RA, upon IA, I can say. This VA upon RA means your VA, it is the electric potential at point A, which is equals to 1, and the current at this point A, it is also 1. So VA upon IA is 1 ohm. Similarly, when you find out VB upon IB, right, you get VB is 2 volt, IB is 1 ampere, is 2 ampere. So this two cancel, again you get back 1. So this is again 1 ohm. So hence, right, from the graph we say that the ratio between the potential difference and the current, okay, of a conductor, of an ohmic conductor, it is always constant. So this point is very important, because when you do the practicals, you shall see that when you take the ratio between V and I, it is always remaining constant. So this is about the resistance of a conductor. Thank you.